Okay guys, welcome back. Okay, you experienced your first day of a flipped classroom. I'm excited to hear what you guys think about it by the end of this, but we're just gonna see how this works, okay? So we are starting with 8.2 today, okay, and it's proving triangle similarity with angle. So if you remember back to first semester, okay, when we were talking about congruent triangles, we used lots of ideas such as side, 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 or angle, side, angle, or angle, angle, side. Remember, the only one that we were not allowed to use, okay, where there's a few that we were not allowed to use for congruency was angle, 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 okay, and then angle, side, side, okay, for obvious reasons, and because, like we saw, it actually truly does not work, okay? So, okay, we're going to talk about one of those that we were not allowed to use, which was angle, angle, angle. They shorten it here to just angle, angle. Okay, and we're going to use it to show that the triangles are similar. Okay, the reason why we only have to say angle, angle is because if two angles are congruent to one another, okay, which you can see here, okay, we know that third angle has to be congruent as well. So if you want to fill that in, you can. Okay, we know that those have to be congruent because in all, okay, the angles have to add up to be 180 degrees, okay? So for example, if this angle here was 20 and this angle was 100, okay, that means this one was 20 as well because it says it's congruent. This one would also be 100. Okay, so that leaves me with 120 degrees used in each one. Okay, that would mean that angle F and C would have to be 60 degrees, which makes them congruent to one another as well, okay? So I just kind of wrote over my letters there, so it's gonna be kind of hard to read, but we'll get through it here. Okay, so our theorem, 8.3 angle similarity theorem, says that if two angles of one triangle, you can abbreviate if you want, are congruent, go ahead and write that there for you, but you can write either version, remember, it's good note-taking skills. So if two angles of one triangle are congruent to two angles in another triangle, then the two triangles are similar. Okay, so if you need to catch up, go ahead and pause the video until you get done. Okay, if not, those of you who are still here with me, okay, go ahead and move over to your pictures. So that's saying that if angle A is congruent to angle D and angle B is congruent to angle E, so those are the two angles that they had marked for us. So if those two things are true, then triangle ABC is similar to, remember we write that with that little squiggly line, the top half of the congruent, okay, similar to triangle DEF. Okay, so example 1, okay, I want to point out this visual reasoning here. Okay, so it says, use colored pencils to show congruent angles. This will help you write similarity statements. So if you need to, okay, C, I'm gonna mark with my blue pen here. Okay, then I'm gonna mark D and G with my orange pen. Hopefully this shows up for you guys. It's kind of hard to draw over these here. And then I have this pink highlighter here that I'm gonna mark our last one with. So that would be H and E. Okay, so if you need to, okay, you can go ahead and look at this triangle. Okay, well, I can tell D and G angles are similar. Okay, then I can tell C looks similar to K if these were to line up well. Okay, and E would go with H. Okay, Okay, so if you need to, you can color coordinate this way. It's just another way for you to imagine these corresponding angles, okay? If you need to, you could also redraw those two triangles, okay? And relabel each part. So my smaller triangle would be C is at the top, D and E. Okay, this was a right angle up by C. I drew mine a little bit too small here. We're 26. Okay, then we have G, K, and H. This was my right angle, and H was 64. Okay, so either way, however you visualize it better to see which angles correspond to one another. Okay, so it says determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Okay, well first I can see that D and G are both right angles. Okay, so those are obviously congruent to one another. So that's one thing I'm gonna write down. So angle D is congruent to angle G, since both are right angles. Okay, well then I know that C is 26, I know that H is 64. Okay, so I know, thinking back, by the triangle sum theorem, okay, all of those angles have to add up to be 180, okay? So I know that 26 plus 90 plus whatever the measure of angle E is, has to add up to be 180. Okay, well that would make then the measure of angle E, if I subtract 26, subtract 90, okay, that would get me 64 degrees. Okay, which 64 degrees is what angle H is. Okay, and looking at E and H, okay, I colored them both orange, or if I look here, they're both corresponding. Okay, so I know that angle E is congruent to angle H. Okay, so triangle. Okay, be careful of the order that you go in here. Remember, it matters. So I'm gonna go G, K, H. It's okay if you picked a different order. Okay, you just need to be careful of how you write the order of your second one. Okay, well G goes with D, K goes with C, and H goes with E. Okay, so in all, that means I have triangle GKH is similar to triangle DCE by angle, angle. Okay, example 2. Okay, so it says show that the two triangles are similar. So visual reasoning over here, okay, showed the other option I showed you up here, okay. It says you may find it helpful to redraw the triangles separately. Okay, so we're trying to look at triangle ABE. So ABE, I'll outline with my blue pen. Okay, it's similar to triangle ACD. Okay, well, they kind of overlap here. Okay, so if you want to, you can redraw those, is what this is saying. Try to draw them big enough this time. A, B, E. Okay, and we know that B is 52 degrees. Okay, and then the other one I'm looking at is slightly bigger. A, C, D. And I know that angle C is 52 degrees. Okay, well automatically, okay, and being careful here in how we write this, okay, I know that angle ABE, okay, looking up here, I can't just say angle B because I don't know if I'm talking about this top angle that's 52 or its supplement down here, okay, so I have to use 3 letters. So angle ABE is congruent to angle, okay, well now looking down here, there's only one angle at angle C, so I can simply call it angle C. Okay, if you wanted to, you could also call it ACD or B, C, D. Okay, again, you can change the order of those, but those are your options there. Okay, so I know that those two are congruent. Okay, and then again, thinking back to last semester, okay, I see this angle A that's repeated, okay, and if you see it here, it really looks like it's the same, okay? So angle A has to be congruent to itself, okay? So angle A is congruent to angle A, okay? By, think back, if I'm looking in the mirror, I see my reflection, so that should make me think of reflexive with an X. Okay, so there are my two angles. So I have one angle there and my second angle here. Okay, so I can say, I'm running out of room here. So I can just repeat what they have here. ABE is similar to triangle ACD by angle. Okay. All right. B. Okay, we're looking at SVR. Triangle SVR is similar to triangle UVT. Okay, so I see automatically, okay, and I don't really need to redraw these because there's no overlap. Okay, if there was an overlap, then you might want to, but I can just leave them the way that they are right now. I see right away that angle SVR, so SVR is congruent to angle, now I need to be careful, SVR, so I go in the same order, is congruent to angle UVT. Okay, those are vertical angles, so by vertical angles, okay. And the other thing that I see that they give me in this picture is that these two little arrows, okay, remember the arrows signify that those sides are parallel to one another, okay? So I can draw this Z, okay, anytime you see parallel sides, you should think of drawing a Z to outline our alternate interior angles, okay? So there they are. So here's one angle, and here's my other angle. Okay, you could have drawn it the other way as well. Okay, it's your choice. So here, with it drawn this way, I have angle S is congruent to angle U. Okay, again, if I just said angle V for my first option, I would have 4 choices. So I have to use 3 letters to signify exactly which angle I'm talking about. But at angle S and angle U, I only have one angle. Okay, so I can just use that one letter. Okay, and whenever I draw that Z, that is called alternate interior angles. Okay, so I have 2 angles congruent to one another. Okay, so by angle, then I have triangle SVR is similar to triangle UVT. And when you get done there, you can turn the page. Okay, up at the top here, we should see some more examples of those. Okay, so it says show that the triangles are similar and write a similarity statement. So it's exactly what we were just doing. Okay, so just 2 more ways that they might show you. Okay, so in example 1 here, okay, or first example, a part of this. Okay, I notice, okay, I'm looking at triangle FGH, so FGH, and triangle RQS. Okay, so we do need to be careful here of what corresponds. So if you need to, okay, maybe this is a good one that we fill it in, okay? So F goes with R. Okay, keeping in mind that all of these angles are congruent. G goes with Q. And H goes with S. Okay, or maybe if you prefer, you can redraw this figure so that it's flipped around so that Q is at the top, matching this G right here, okay? Up to you, whichever way that you prefer, okay? I just happen to have colors here, so this is the route that I took. So I see that all of these angles are congruent to one another no matter what, okay? So basically you can just pick two sets. So I chose angle Q is congruent to angle G. And angle F is congruent to angle R. Okay, you could have chose a different one. Okay, as long as we have two that we are listing, we've satisfied everything that we need to use angle, angle. Okay, so by angle, angle, we have triangle FGH is similar to, remember that's that little squiggly line, triangle RQS. Okay, so that was number 1. Okay, number 2 here. Okay, well, I know that this bottom side here creates a straight line, so my other side here is also a right angle. Okay, those are supplementary. They have to add up to be 180. If one side is a 90-degree angle, so is the other. Okay, so automatically I can see that angle DFC is congruent to, now be careful, I can't go back to DF again, okay, because DF was this triangle's shortest side. Okay, so that means that D, okay, corresponds to E, okay? So instead, this time I say angles E, F, D, okay? Both are right angles. Okay? So then I'm going to use the triangle sum theorem here to solve for this angle right here. So I know that I have 90 degrees plus 58 degrees plus the measure of angle D has to be equal to 180 degrees. So that means then that the measure of angle D has to be equal to 58 degrees. Okay, and I should be careful here, okay? I can't write just the measure of angle D, so I'm gonna go cross that out. This is why we use pencil in math. Okay, I need to call that the measure of angle EDF. Because if I just said D, you wouldn't know which triangle I was talking about here. Okay, so again, fix this one. The measure of angle EDF. That looks much better. Okay, well, sorry, this is not equal to 58. Whew, getting on a roll here, I need to slow down. The measure of angle EDF then would have to be equal to 32. So we'll just get rid of all of this here. Degrees. So if I subtracted 90 from 180 and then 58 from 180, you would get 32 degrees. Okay? So what I was getting to then is that we have some congruent angles. Getting ahead of myself there. So we know that angle EDF is congruent to angle, okay, now we have to be careful again, so EDF. So I start with my longest side here, so I'm gonna go DCF. Okay, and that was by the triangle sum theorem. Okay, so now I have one angle, two angles, so I'm good to go. So by angle, angle, triangle CDF is similar to triangle DEF. Okay, so that was number 2 there. All right, solving real life problems. This is probably one of my favorite problems of this lesson here. Okay, so it says, previously you learned a way to use congruent triangles to find measurements indirectly. Another useful way to find measurements indirectly is by using similar triangles. Okay, so our example here says that a flagpole casts a shadow that is 50 feet long. It's probably important. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is only 40 inches tall. So it says, how tall is the flagpole to the nearest foot? Okay, well, the first thing that I need to do, okay, is probably change all of this. Okay, I need to change my 5 feet 4 here into inches. Okay, so let's see here. Yes, I'm gonna change it into inches. So to do that, we take 5 feet. Okay, well, there are 12 inches in a foot. Okay, so that gives me 60. And then I have these remaining 4, so that would be 64 inches. Okay, then I have 40 inches here. Okay, so that's good. Then I have, let's see here, 50 feet. Okay, so as long as I have feet over feet and inches over inches, we are okay. Okay, so I don't have to change my 50 feet for my flagpole. Okay, so I like to think of this as a picture. Like I've said before to you guys, I'm a very visual person, and I need to see this lined up together and looking like 2 similar triangles. So as you can see over here, I'm going to kind of mimic this picture. Okay, so I have this flagpole. Remember, we don't judge pictures in here. I'm no art teacher. Okay, and then this shadow on the ground. Okay, if I pretend to connect these, it makes a triangle. Okay, I don't know how tall my flagpole is, so that's X. And I know that its shadow is 50 feet. My woman, okay, again, no art teacher here, is 5 foot 4 inches, okay, or we just said that that is the same thing as 64 inches. Okay, her shadow is 40 inches long. Okay, triangles are not drawn to scale, okay, just trying to get a visual here. Okay, so I can see what corresponds together, okay, and that'll help me write a ratio. Okay, so I know that X corresponds to 64. Okay, well, with X becomes 50 over 40. Okay, if we cross multiply and divide, I'm going to get 40x equals 3,200. Divide by 40. Again, you can do this all in one step in your calculator if you want. X is equal to 80. Okay, so the flagpole is 80 feet tall. Okay, and that was our real life example. Again, I really like this problem. Okay, so you might want to keep this one in mind of how we drew our pictures, how we set up the ratio, and how we solved. Okay, and that is actually the last example then for our second lesson. Okay, so again, just be thinking of any questions you have. Go back and reread through your theorems, through your examples that we've done, and see if you have any questions for me whenever you come into class tomorrow.